So in this problem, I have a picture being suspended by two wires. Okay? So I'm going to say I have a wire A, and let's use another color that's kind of a contrast to that. How about red? And then wire B. Okay? So I've got wire A and wire B, and I have a spring scale set inside each one of those wires. And the spring scale is reading that the tension in the wires is 20 newtons. Okay? And I've used a protractor and I've measured that this is 45 degrees. Okay? What I want to do is I want to determine the weight of that picture. Okay? So got these two spring scales that are telling me that the tension here is going to be 20 newtons and the angle, measuring using a protractor, is at 45 degrees. And what I want to do is determine the weight of the picture from the data I have. Well, there's my drawing. What I want to do is I want to go to a free body diagram, okay, which is going to look awfully similar. Okay, so grabbing my green, here's my picture. The three forces that are acting on my picture are first gravity, which is mg. Okay, I have tension, what does I say? Tension B and tension A. I forgot to put an arrow over there on tension B, so let's put that arrow on there. Some happy little trees. And what I know is that this is equal to 20, this is equal to 20, and that there's an angle of 45 degrees here. Okay? So what I'm now going to do is I'm going to set up a coordinate system. Now there's a couple of ways to do this. I would almost be tempted to create a coordinate system which puts my tensions on axes. Like this, make this my x, this my y. But because I am looking for the weight of the object, I'd rather have the weight be its own axis. So my coordinate system that I'm going to create is going to look like this. Here's my y, and here's my x. Okay? So everything up is going to be a positive value, and everything to the right is going to be a positive value in the x. So now what I'm going to do is I'm going to start looking at my vectors. Well, the first vector I'm going to look at is my weight. Now, my weight is entirely in the negative y direction. Okay? It's entirely in the y. There's no x component of it. Now, looking at my tensions, there's a component of this tension that's in the y direction upwards, and there's a component of this tension that is also in the y direction. Okay? Cool? Now, looking at the x-axis, I'm not really all that concerned about, but for completeness, I do have a component of that tension in this direction, and I do have a component of tension in this direction. But because I'm only concerned, my only thing I'm looking for is the weight of the picture, I'm not concerning myself with those two vectors. Now, there are situations in which I would, but this is just not one of them. Now, I'm going to take this vector and I'm going to look at it closely. Okay? This is a vector of length 20 newtons, and I'm looking for this component of the vector, the component of the vector that's entirely in the y-axis. Okay? Cool? Now, I'm going to put in, there's my x, there's my y. I can see, just based by the fact that they're y and x axes, that there's a right angle there. And I also know that this is 45 degrees. Okay? Now, I need to solve for that. What is the size of the vector over here? The component of this vector that's pointing in the y. Well, knowing the little bit of trig I do know, that looks like it's my opposite. This is my adjacent. This is my hypotenuse. So looking for the opposite, there's only two trig functions that I can possibly use, and that's sine theta is equal to opposite over hypotenuse, and tangent theta is equal to opposite over adjacent. One of those two is going to be giving me the correct answer. Looking at the information I have, I do have my hypotenuse and I don't have my adjacent. So the winner is sine. Okay? So sine of my angle that's opposite, so that's 45 degrees, is equal to opposite over hypotenuse. I move the hypotenuse over to the other side, and I'm left with h sine 45 is equal to opposite. Now my h in this case turns out to be this 20 newtons, the tension. But I'm going to leave it as h for right now until I'm ready to just plug in numbers. Okay, the first thing I'm going to do is I'm going to use my calculator, clear, and I'm going to check my mode. It's in degrees. My angle's in degrees, so I'm good to go. Now I'm going to hit sine, which is this button right here, 45, and then close the parentheses and hit enter. 707, there's an interesting thing about 707, but I'm not going to go into it right now. That means this right here is equal to 0.707. Okay? So I'm just going to put that substitution in right now. 0.707. And remember, that's what I'm getting from right here. 707. Okay? Now, the hypotenuse was the tension. Now, the value of the tension is 20. So I'm just going to put 20 newtons in there. Okay? So we've got 20 newtons times 0.707, which is going to give me the opposite. Give me the y component of that vector. So times 20 gives me 14.14. I'm just going to round that up to 14. I'm going to round it down basically. I don't really want to carry the digits too far out. Okay? So 14 newtons. Okay? So that means that there are 14 newtons in this direction. Now, because of the symmetry, because that these two angles are the same, and because the tensions are the same, I know right now that this is 14 newtons too. It's the exact same process. Okay? Cool? Now, I'm going to erase all of this, and we're going to re-examine our free body diagram. Okay, here's my picture. I have my weight down, which is mg. I have one component of my tension up at 14. I have another component up that's 14. And then I have these two other tensions in this direction that I'm not concerned about. I do know that they're going to be equal to each other, and they just simply don't apply. Okay? So now all I have to determine is the weight of the object. Well, that is this vector plus this vector minus this vector is going to be equal to 0. That's Newton's second law. Sum of my forces is equal to mass times acceleration. Hopefully your picture is not falling, so the acceleration is going to be equal to 0. So that means the sum of the forces is equal to 0. It's a balanced system, which means that all of my upward vectors equal to my bottom vectors, but expressed this way would be 14 plus 14 minus mg, because it's pointing down, equals 0, or 14 plus 14 equals mg, or 28 is equal to the weight of my picture. Now, if I were trying to determine the mass, at this point I just simply divide by g, which is about 10. Okay? Cool?